Okay, in this example, it says to find the z-score. A population has a mean of 7, a standard deviation equal to 2. Find the z-score for a population value of 5. So they want to find the z-score when x is a 5. If you recall from the PowerPoint for section 3.3, here's the formula right here. Z is equal to x minus mu over sigma. So I go back and I do z is equal to x, which is 5, minus 7, which is mu, divided by 2. So it's negative 2 over 2. So z is equal to minus 1. For b, they're saying when x is a 10. So I do the same formula, 10 minus 7 over 2. So that's 3/2, which is 1.5. And what number has a z-score of 2? So this time, they're giving me the z of 2, so I have to take this formula here, x minus mu over sigma, and rework it so that it's solved for x. So I multiply both sides by sigma. So I get z times sigma is equal to x minus mu. Add mu to both sides. And that gives me x is equal to z times sigma plus mu. So now I can put in my numbers. X is going to be 2, because that's a z. Sigma is 2, plus mu, which is 7. So x is going to be 4 plus 7. So I get x is equal to 11 on that one. All right, let's try this one. For the data set, find the first and third quartiles. First thing I have to do is put the data in order. So the smallest number is a 4. Takes care of that one. 10. 20. 25. 31. 36. 37. 41, 44, 41, 44, 68, and 82. 68 and 82. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So the quartiles, when I'm looking back at the PowerPoints, is right here. Arrange the numbers in order. Let n be the number of values in the data set. So now I want to do 0.25 times n and 0.75 times n. So for the first one, I'm going to do 0.25 times n, which is 11. So I do on my calculator 0.25 times 11, and I get 2.75. And then I want to do 0.75 times 11, 0.75 times 11, whoops, 0.75 times 11, 8.25. Okay, now I go back here and it says if L is a whole number. Well, it's not a whole number. It's rounded up to the next higher whole number, and the quartile is the number in the position. All right, so I have to round up. So this is going to round up to 3. This is going to round up to 8. Oh, to 9. So again, you're rounding up. All right, so the number in the third position is 1, 2, 3 is the number 20. And the number in the 9th position which is quartile 3. 1, 2, 3, 4, 5, 6, 7, 8, 9 is 44. Find the IRQ. IRQ is Q3 minus Q1. So I get 44 minus a 20. So that's a 24. Find the upper and lower boundary limits. All right, so the upper and lower boundary limits. Let me get to those questions so you can see where I'm getting the formulas from. Here it is right here. The lower boundary limit is Q1 minus 1.5 times IQR. So it's going to be Q1 minus 1.5 times IRQ or IQR. And then the upper boundary limit is going to be Q3 plus 1.5 times RQR. So it's going to be 20 minus 1.5 times 24. This one is going to be 44 plus 1.5 times 24. So 1.5 times 24 is a 36. So 20 plus 36. Which is a 56. And then this is also a 36, but this is 44 plus 36. So that's going to be 80. So those are the upper and lower boundaries. And it says, list all the values, if any, that are classified as outliers. So the outliers, according to this, is any data value that is less than the lower boundary or greater than the upper boundary is considered an outlier. So let's see, 56. Oh, this was minus. This was minus, not plus. That was minus, so this is a minus 16. Well, there are no numbers less than negative 16. However, there is one number greater than 80, so the outlier is going to be 82. All right, this is the one we just did. Percentile. Find the 58th percentile. All right, so percentiles are on the PowerPoint right here. That was getting the value. Let's go back. Here it is, not that one. It's this one right here. Make sure the data is in increasing order and is 45. So we want the percentile over 100 times how many there are. And again, this gives us the position of the number, not the actual number itself. Okay, these numbers are already in order. So let's see how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 12 times 4. So there's 48 numbers. So the percentile then is going to equal, for the first one, L is equal to 58 over 100 times 48. So 58 divided by 100 That gives me 0.58. And I want to take 0.58. So I want to take my answer and multiply that by 48. And that's going to give me 27.84. All right, so let's go back. And it says, if L is a whole number, it's the average of the numbers in the positions. It's not a whole number, so I round up, always round up to the next higher whole number, and I get that number in that position. So I round this up to 28. So the number in the 28th position, that's 12, 24, 25, 26, 27, 28, is 34. So the number is 34. Find the 22nd percentile. So the 22nd percentile, same way, 22 divided by 100 times 48. So 22 divided by 100. So 0.22 times 48 is 10.56. I'm going to round up that to 11. So let's see, the 11th number is 14. So the number is 14. C, find the 78th percentile. Same way, 78 divided by 100 times 48. So this is going to be the position. So 0.78 times 48 is 37.44. Round up to 38. So 12, 24, 36, 37, 38. That's the number 40. And finally, the last one is the 15th percentile. So 15 divided by 100 times 48. So 0.15 times 48 is 7.2. I round up to the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. It's the number 8. So that position and that number are exactly the same.